Now it's time for our first talk, who is going to be given by Professor Shuly Wintner from the University of Haifa at Israel. Professor Shuly Wintner will join us at the stage. I'm going to present you briefly. Professor Shuly Wintner is the professor in computer science at, as I said, at the University of Haifa. His research interests are very broad. He is interesting and is working in the field of natural language processing, formal description of the natural languages, machine translation, which is very hot topic, and also multilingualism. Probably I missed something from his area of interest. That's why I'm going to ask Professor Shuly Wintner what actually are current topics of research.
As you said, there are quite a few, but I think that the most fascinating thing I'm interested in now is code switching. That's the phenomenon whereby when we speak more than one language and we talk to each other, we tend to switch between those languages all the time, typically without even being aware of this. Israel is a very multilingual society. We have about 50% native Hebrew speakers, but about 20% native Arabic speakers, about 20% native Russian speakers, a lot of native English speakers, and so on, and people speak languages all the time. It's a wonderful real lab to explore this phenomenon. We don't know much about code switching, especially not in the written language, like in social media, and I'm really excited to work on it.
Okay. I also would like to mention that at the moment Professor Wintner is serving as the Deputy President of the European chapter of the Association for Computational Linguistics. Because we are scientists and we are keen about new inventions, about what is going to happen in the field of all directions of the science, I would like to ask one more question, Professor Wintner. What is the most important or the most amazing fact or facts from science actually you would like to share with us? Not only from the area of computational linguistics. Share with us something which amazed you.
That's actually extremely easy. Outside linguistics, okay. That's AlphaFold. DeepMind, this company owned by Alphabet, the owners of Google, developed AI-based algorithms that were used to unfold, reveal the structure of proteins in a way that we could only dream of until 2 years ago. They exposed AlphaFold about a year and a half ago, I think, and very recently, like last month, they came up with the main results. They have a structure of 200 million proteins now. This is mind-boggling. This opens the road to developments in medicine, in immunization and vaccination, who knows what. That's mind-boggling. Learn about it, read about it, it's fascinating.
Okay, it's very interesting, but let's come back to the computational linguistics and natural language processing, and now I'm glad to give the floor to Professor Shuly Wintner for his invited talk. The floor is yours.
So, thank you very much, Svetla, for this introduction. And also many thanks to the organizers for inviting me here. I've been in Bulgaria once, and that was almost 25 years ago. It's amazing how Sofia changed since, at least from my memories. I'm very, very happy to be here, so thank you very much. Let's see if I know how to operate this. That's a clicker. That's the clicker. Yes, that works. Okay, I'm good. So, good morning, welcome, thank you for coming here. I'm going to talk about the Hebrew essay corpus, which is a project that I've been involved in the past 3 or 4 years. And I'm going to give an overview of the project, starting by the motivation, going on to the development of the corpus, its annotation, its evaluation, and a few use cases. And I thought that this would be good topic to discuss here in Bulgaria because, as Halichuk said earlier, Bulgaria has such an amazing history of development of language resources, especially for such a small language. I'm talking about the number of speakers, of course, not about the importance. So Hebrew is also a small language with about, I think, maybe 10 million speakers, but only half of which are native speakers, and this is going to be evident in this presentation. So why do we need learner corpora? The reason that we need learner corpora stems from the fact that about half the world's population today is bilingual or multilingual. And in order to understand multilingualism and bilingualism, we need resources, and in particular, we need corpora that reflect learner language. When I say learner language, I don't necessarily talk about people who are actually actively involved in studying a new language. I'm talking about people who are non-native speakers of the language. So for me, learner and non-native are going to be synonymous. Such resources, such corpora that reflect non-native language are extremely important for research if you want to understand cognitive linguistics, language development, language acquisition, and learn language loss also. But they are also important for studying bilingualism, multilingualism, cognitive linguistics in general. And of course, they have some practical uses as well. So if you want to develop applications for language learning, language education, error prediction, error correction, also forensic linguistics applications like native language identification, you need language resources. One specific practical application that comes to mind for this work is automation of language aptitude tests. And I'll talk about language aptitude tests because this is where the bulk of our corpus comes from in a few minutes. When you look at what language corpora exist out there, you see a broad picture. There is a beautiful website called Learner Corpora around the world, and it lists corpora for a great variety of language pairs. Okay, when we talk about learner corpora, we always talk about two languages: the non-native language or the target language, that's the L2, and the native language of the speaker, that's the L1. So if you look at the website, you see that there are almost 200 data sets listed there. As you would expect, about half of them, more than half of them, have L2 English because the world studies English. But even in the other half, there is not a single data set with Hebrew as the L2, only 2 data sets with Arabic as the L2. And if you look at the L1s, the picture is still very, very sad. Only 6 corpora have representations of Arabic as native speakers, and none has Hebrew. So that's part of the motivation for this present work. You see the entire? No, you don't see the entire, but that's the motivation for it. Okay. So when we started with this project, we had multiple goals. One of them was, of course, to compile a corpus of essays authored by non-native Hebrew learners. But we also, it was very important to us, we also wanted to have a comparable corpus of native Hebrew authors in order to facilitate comparative analysis of the type of language that's used by learners and by native speakers. We wanted the corpora to be represented uniformly so that they can be searched together and used together. We wanted the errors in the learner corpus to be annotated in some way. I talked a lot about what is an error and how we wanted to indicate errors and even suggest corrections. We try not to call them errors or corrections, but I'll get to that. And finally, the ultimate goal was to use the corpora for comparative analysis. We had a secondary goal, which was to create corpora of Hebrew as the native language, and there the target language is English. And if I will have time, I may say a few words about this other project, but the bulk of this presentation is going to be dedicated to a corpus of Hebrew as the target language with native languages, with speakers of 3 native languages, Arabic, Russian, and French. So here are some data about Corpus. We have 3,000 argumentative essays. These are the type of things that you're requested to write when you take a language aptitude exam, when you want to be admitted to a university, or you want to, study in the United States. The TOEFL test is like that, and so on. So we have 3,000 essays authored by native speakers of Arabic, Russian, and French, 1,000 each. And we have 1,000 essays of a similar form that are authored by Hebrew native speakers. The native essays were authored as part of what's called the psychometric exam. This is an exam that all students, prospective students who want to be admitted to Israeli universities have to take. The non-native essays, I should say, those exams are administered in several languages. You can take the psychometric exam, you can take it in Arabic, and then you will write an essay in Arabic. You can take it in Russian, you can take it in French, in Spanish, in Portuguese, several other languages. But if you decided to take the psychometric exam in the language that's not English, that's not Hebrew, then you have to take an additional Hebrew aptitude exam, and that's the Yael exam. And this is where we get the non-native essays. People who take the Yael exam are students, prospective students who did not take the psychometric exam in Hebrew, and therefore they had to pass an exam in Hebrew proficiency, which includes an essay. Now, those essays are different from the essays that native speakers write when they take the psychometric exam. In particular, they have different sets of prompts. Prompts are the topics that you're requested to write about. So different sets of prompts. They have different lengths. So students are requested to write, I forget, maybe 10 to 15 lines, I think, for the Yael test. That's something like double that for the psychometric test. And there are a lot of different times. So the non-native exams are shorter, the native exams are longer. The time they have for essays is longer. And so you get different types of essays in the end, but they're as comparable as possible. The conditions are very similar. It's a test condition. You have a lot of time. You have to write it down. They write with pencil and paper. They don't type and so on. So that's the best we could hope to have in terms of the comparability of the native and the non-native essays. Some metadata. So for the native essays, we have almost nothing. I wanted to move this bullet to the front. Anyway, for the natives, we have almost nothing. We have just the grade, and the grade is, I think, between 1 and 6. For the non-natives, we have a lot of metadata. We have the gender, age, year of exam of the authors. We have their parental education, some demographic information such as family income. All these things are important if you want to do analysis. We have the prompt, the actual prompt, the topic that we were asked to write about, and we have the score. And the score consists of 4 components: content, organization, linguistic richness, and linguistic precision. I'll talk a little bit more about each of those in the next slide. Each of those components is scored 1 to 7. So the total score of the non-native exam, the A exam, is between 4 and 28. Remember this 4 to 28 range. And then, as I said, the only available metadata that we have for the native speakers is their score, and this is 1 to 6. What are those components of the score? So how is the score of an essay determined? So content asks, I should say, those essays are given scores by human raters. I had the logo here, but I forgot to acknowledge the contribution of the the National Institute for National Institute for Testing and Evaluation, NITE. Okay, we have the Hebrew acronym, so I forget the English acronym. NITE is the institute that administers those exams, both the psychometric exam and the Yael exam, and they were kind enough to give us access to some of those essays. I'll say a bit more about that. And back here, NITE hires, I guess, teachers to rate those essays, and the teacher has to give a score of between 1 and 7 to each component. So content has to determine whether the text follows an overall idea and whether it adequately answers or responds to the actual prompt you want a student to write about what they were asked to write. And then there is organization, and you understand what that is, the logical structure of the essay, of the argument, whether the argument is coherent. Then there's linguistic richness, which is basically vocabulary richness, maybe also richness of syntactic structures. And finally, there is linguistic precision. That's the correct use of words in context, both content words and function words. Now, here's a question for you. Which of those things, which of those four components would you think that an algorithm would best predict? So one of the tasks that we have in mind is to be able to automate the process of scoring those essays, right? This is one of the applications that motivated our work. And in order to automate the process, we need to predict the score of between 1 and 7 to each of these four components. Which one do you think is going to be easier and which one is going to be harder? I leave that for you to think about. I will show you an answer, not the answer, later on, because we did do this task. All right. Again, some fun facts about the corpus. So as you see, we have 4 native languages for the AL essays and native essays. And if you look at the, do I have a mouse here? Can you see the mouse? Yes, you can see the mouse. So if you look at the length of the essay in terms of tokens, you see that the Hebrew native essays are more than double the average length of the non-native essays. And this is not just because they're natives. That's mainly because they were requested to write longer and they were allotted more time. Okay, so that makes sense. If you look at the non-natives, you see that there is not much difference in terms of tokens between the 3 L1s. And the table shows it very clearly. The average number in tokens is very, very similar. The average number of sentences is very different. And we think we know why. The reason that there are fewer sentences in Arabic, this is not Arabic. This is Hebrew authored by people whose native language is Arabic, of course. And we believe that the reason is what we call transfer from L1. Arabic has longer sentences because Arabic uses fewer punctuation marks than other languages in particular. And because Arabic uses fewer punctuation marks, they tend to have longer sentences with conjunctions, coordinating conjunctions in them. This transfer over to their non-native language and is reflected in their Hebrew. And this is the kind of things that you want to find with the help of language resources such as the essay corpus that we are developing here. So we'll see more about that later on. There is, of course, this is the distribution of essay scores. This is important. What you see here is the distribution of the non-native essay scores that range between 4 and 27 by L1. And there is Arabic, French, and Russian here. You only see 2 lines because the Arabic and the Russian are identical. They're just overlapping. Only the very end do they differ a little bit. And this is by design. This is not an accident. Knight had a plenitude of essays, and he asked them to sample the essays in a way that would give us these beautiful plots. Okay, this is what we asked. Now you see that there is a bell curve here, right? It's a normal distribution, but it's cut on the left. And that's again by design. We looked at some of the essays with the lower scores, and it was just word salads. There was nothing, or almost nothing there. And we decided that we won't be able to apply any computational tools to those lower scored essays. We wanted to run morphological analysis, we wanted to run parsing and so on, and we just asked the Knight to cut it on the left. So we have essays that were scored 17 and above. One more word about the scores. All those scores were given by 2 human raters, and we take the average. So sometimes you have a score that is not integral, okay? It can be half. All right. This is again not very surprising to anybody who's working with non-native language. This shows you the a plot of the length of the essay versus the score. And the number of sentences doesn't give a very good picture. Those are the vertical bars. But if you look at the function itself, the graph of the function itself, then you can see that there is a clear correlation between length and score. The longer the essay, the higher it is scored. Another question. What do you think would happen if we just use the length of the essay to predict the score? Just the length, not even look at the words, just the length. It's a good question. We never checked that, but I think that it would give us a very good correlation. Okay, once we obtain the corpus, we have it in-house, represented as we like. We start with an annotation campaign, and the annotation campaign, unfortunately, did not annotate the entire corpus. This is just because of time and money, but we did annotate 1,000 non-native essays. And we did select those 1,000 in a very representative way. In addition, I should say that a little more than 50 essays were annotated by 2 human annotators to measure interorder agreement. Those annotators these were people that we hired. Okay, we're out of Knight now. Okay, Knight provided us the scores as given by 2 human raters, but now we're doing annotation of a completely different manner. Our annotators are native Hebrew speakers. All of them are linguistics graduates. And the idea was to indicate errors and to suggest corrections. But I use caution here. Errors are in learner language. Errors would be deviation from standard language. But what's standard language? You know, different people speak different languages. We don't have a definition of the standard language, and we don't believe in prescriptive rules because native speakers do not comply with prescriptive rules. So the idea was to find something that correlated with the linguistic intuitions of our linguist annotators. So I know what sounds native to me and what sounds non-native to me, and this is the best definition that I can come up with. Once you find a deviation from the standard language, from my linguistic intuitions, you mark it. And then you suggest a correction. And the idea in the correction is not to try to figure out what was in the author's mind in the first place, because we will never know that. So the idea is to bring the sentence to syntactically valid version by minimal number of corrections of changes. Okay, so it is minimal edit distance between the original and something that goes through our parser with no errors or something like that. So that was the idea. We call these corrected sentences target hypothesis. They are hypotheses because we do not really know what the author meant, because we can't talk to the author. The idea is to enable automatic processing. And I want to give you a few examples of the kind of annotation that we employed, but in order to do that, I need to teach you some Hebrew. So brace yourselves. Hebrew is a different language from the Slavic languages that many of you here speak, or the English that we all speak, but I'm not going to really teach you. I'm just going to give you some fun facts. Okay, so Hebrew is a Semitic language. It has a main word formation or derivation of morphological process called root and pattern. The idea in root and pattern is that most words, in particular verbs, but also adjectives and nouns, are based on consonantal roots. The roots have usually 3 consonants, just consonants, even they are not, they're morphemes, they're not pronounceable. And the patterns are strings of vowels and consonants that have open slots in them. And in order to form a new word, the language takes the letters, the consonants of the roots, and inserts them non-linearly inside the slots of this pattern, thereby yielding a lemma. And all of our verbs are formed this way, many of our adjectives, many of the nouns as well. It is highly inflectional, so verbs inflect for number, gender, person, tense, and they have to agree with their subjects on all those. And nouns have grammatical gender. I guess Bulgarian is similar. Adjectives inflect for number, gender, and definiteness. I think that Balkan languages also have agreement on definiteness. So Hebrew is also like that. Nouns have to agree with their adjectives on all 3, so number, gender, and definiteness.
不是得那个吗
？2年以后是矫正得5岁以后。
Prepositions also inflect for number, gender, and person. These are like clitics that attach to the end of the preposition to indicate what the object of the preposition is. And possessives may be cliticized on nouns and on prepositions to indicate the possessor. So there's a lot going on in terms of inflection and morphology, and all these things have to be learned. If you speak Arabic, you're familiar with many of those. If you speak French, less so, or Russian. The script. So it's not just about morphology, it's also about orthography. What can you do? You write those essays. The script is right to left, that's not a big problem, but 5 of the consonants have different shapes at the end of words. If you're familiar with Greek, this is like the sigma of Greek. Several consonant pairs are homophonic, so the word can, yes, can either be written with a kaf, as you see here, in which case it would be yes, but it could be written with a kof, as you see here, in which case it would be the noun nest. Identical sounding, but very different. And the other way around, the single letter pei here is a heteronym, so it can be pronounced is either like a P or like an F, tzipa versus tzifa. Okay, and this happens with 3 consonants, so it's pretty common. Of the 5 vowels, 3 can be omitted, and 2 are almost always omitted. So we have 5 vowels, a, e, I, o, u, but only 2 to 3 of them are actually present in the writing. Okay, and this is one of the main obstacles when you start learning to read Hebrew, because you see things like that. So if English were written like Hebrew, this is how you would see. How you would try to read, okay? It's comprehensible, right? You know English, you know what's written there. So get used to read many words with very few vowels, but it's not easy, especially if you're not used to it. Several function words, that's another obstacle. Several function words, the definite article, coordinating article, conjunction, the subordinated article, 3 prepositions are attached in the script to the word that just happens to follow them. So again, if English were written like Hebrew, Jabberwocky, I won't be able to see because it's too low, would be written like that. The slides are available, I've sent them, so, and I'll be able to make them. Okay, so all these things make Hebrew difficult, and that's why learners make mistakes, like all learners in all target languages. I'm going to show you a few examples of the kind of things that we correct, okay? So this sentence says, a lot of students decide to continue the studies. The word in red here is misspelled. Luckily, in this case, the misspelled word is a non-word in Hebrew, okay? So that's easy. You have the gloss here. I took the liberty of writing Hebrew, the words in the sentence from left to right, so that the word by word gloss is more natural. הרבה תלמידים מחליטים להמשיך את הלימודים should have been להמשיך, you know that's an age, להמשיך, להמשיך, those ages are often omitted in fast speech, so the age was missing here. We simply mark the fact that להמשיך is not a valid form, and we suggest a target hypothesis, להמשיך, to continue. That's easy, that's non-controversial. The problem with Hebrew is that in many cases, a single error, like omission, deletion of a letter, or addition of a letter, or transposition of 2 adjacent letters, or the replacement of one letter by another, would yield a valid word. Because we don't have vowels, and because there are all those issues with the orthography, in a lot of the cases, you make a single mistake, you end up with a valid word. And that's why we can't just say, okay, if the sentence is syntactically valid, then we don't correct. And this is an example that I want to show you. This one says it will only come to the warm of the family itself. Warm, warm. זה יבוא רק לתולעת המשפחה עצמה. That's a perfectly syntactic, grammatical sentence in Hebrew. Of course, if the family happens to have a pet worm, then and they buy pet food for it, the worm, then it will come probably to the worm of the family. But this is not what's going on here, because the prompt doesn't talk about worms, and because the context shows us that this is totally unrelated semantically. And therefore, we'll take the liberty and do suggest a correction. And the correction has to do a transpose of two adjacent characters. This is not tolat, warm, this is toelet, benefit. It will only come to the benefit of the family itself. That makes much more sense in context. And we do mark that as the target hypothesis, even though the author wrote about worms, we know that they meant this is a really funny example, but it will take me too much time to explain. The sentence says it's very good to sell many sofas. The sentence does not talk about sofas, and it does not talk about selling. Sofas are actually languages, and selling is actually learning. But it'll take me some time to explain why this is the case. We do take the liberty of going further and figuring out what the author meant here. With no doubt, the author is a native speaker of Arabic, because the mistake here has to do with the root and pattern system that Arabic speakers are familiar with. They don't know the Hebrew system, but are familiar with that idea of the system, whereas the French and the Russian learners are not. So this is definitely a mistake by our speaker. And of course, there are standard things like, wrong usage of prepositions. In this particular case, we cannot forget about bad things. Hebrew doesn't need the about there, so we mark it as redundant, and that's another error. And sometimes we have no idea what the author said. No idea. And we just leave it as is. We mark it as an error, but we do not provide any target hypothesis. And this is, of course, more common in the lower graded essays. Skip this. I'm going to skip the codes as well. How am I doing with time? I have until half past. I have until half past, including questions. Our representation is vertical. We list each word in its own row, and then have very complicated codes to indicate the type of things that go on here when there are deviations from the standard language. I won't bother you with the details, they're not very important, but you can see that some sentences have lots and lots and lots of marks or annotations, which reflect quite serious deviations from what we would call standard language, and we indicate all of them. Here's another one. Just look at the red tokens in the Hebrew original sentence, and you see that there are spelling errors here. There's wrong agreement here. There are problems with prepositions, with pronouns, and so on and so forth. All this is coded and represented in uniform. A word about the evaluation. As I said, we actually employed 3 annotators, but we used 2 of them for the inter-annotator agreement. That was at the very beginning of the project when the annotation scheme was not final yet, so this is speculative. In any case, what exactly are you counting when you do intercoder evaluation of intercoder agreement evaluation? It's a question. So we have 2 measures here. One of them is whether the annotators agreed on which words needed to be corrected. And with this, we have something like 95% agreement rate. This is a binary question. If they annotate the same words in the essays that they worked on, the 54 essays that they worked on, and they agreed in 95% of the cases. If you ask whether they gave the same code to those words, you get less than 50% accuracy or agreement between them. And this is because our codes are extremely complicated, and sometimes the codes require being innovative, because you need to know that warm is actually benefit. And sometimes you may have more than one way to suggest a target hypothesis that's valid. So These are the data. Okay, I want to talk about some use cases now. And the first few slides, these are brand new. I just got the information 3 days ago. And these are some analysis that we did with the types of errors made by different speakers according to or divided by their L1. So here's a few types of analysis that we ran. So for instance, you can see that the Arabic, French, and Russian speakers made errors in the sense that we had to annotate thousands of tokens in their essays. This row, the first row here, is not very indicative. You know, some people make more errors, others make fewer errors. But once you start looking at the types of errors, and this is what are elaborate, complex codes or tags, if you like, enable us to do, then you start to see a different picture. So for instance, if you look at errors that are related to the non-linear templatic morphology of Hebrew, those root and pattern errors, you see that Arabic speakers make about twice as many errors than Russian speakers. And that's the issue that I talked about earlier, because they are familiar with the system. They just don't know to employ it properly. For the French and the Russian native speakers, words are probably more cohesive units. They don't have a way, or they are not used to splitting words derivationally to their morphemes, whereas the Arabic speakers can and make mistakes there. Another interesting observation. So you see that there are differences in things like agreement and argument structure and conjunctions. But look at conjunctions now. Errors in conjunctions. Arabic speakers make many more errors with conjunctions than the other non-native speakers. The p-value is 0. And the reason is probably transfer from L1, because the special use of conjunctions in Arabic, that's reflected in their L2. On the other hand, if you look at determiners, for instance, the Russian speakers make more than double the number of errors in determiners than the Arabic and the French native speakers. And again, you can understand that as transfer from L1, because Russian does not have determiners of the type that we have in any case. So this kind of analysis is now facilitated by the Corpus, and in particular by the very complicated coding scheme that we devised. It's a 55-page scheme, but the information that's encoded is extremely useful. Next, we ran a few classification tasks on the data set, because that's what we know how to do. And we defined 3 tasks. One is to distinguish between native and non-native speakers. One is to identify the L1 of the author. And the interesting one is to predict the score, the proficiency score. And again, we don't do that because we want to automate the processes for night. This is not the business that I'm in. I'm in the business of understanding language. And I think that using classification, even simple, old-fashioned statistical classification, can give us a very good vehicle into understanding linguistic issues just by looking at the features that do the work for you. And this is the kind of methodology that I've employed in the past over lots of other tasks, like distinguishing between, men and women, between original and translated texts, between texts of authors from different L1s, and we do that here as well. Same methodology, and it sheds light on the kind of differences. This I don't have to show. As I said, the features should be crafted. We're not using deep learning here because we care about the features, and we want the features to reflect the kind of things that we think would help us achieve the task, in particular, distinguish between natives and non-natives, between non-natives of different L1s, and predicting the score. Okay, what is it in the feature? features. So we use length features, numbers of tokens, numbers of average length of sentences, and so on. We use functional morphemes like prefixes and suffixes and function words. We use characters, specific characters, like the ones that have different forms at the end of the word, or the ones that are homophones. We use lexical richness, so various type token ratio measures. I'm sure you know what that is. The number of words in the sentence, the number of unique words in the essay divided by the number of words in the essay, that's PTR. And we have like 5 or 6 different measures of PTR. Features from phonetics, from orthography, from discourse. We use discourse markers because the organization of the text is important. And word frequency, we don't actually use the frequency or the rank, we just bin everything to 4 or 5 bins, I think. Just look at whether a word is common or less common. And here's what we find. So the first task is extremely simple. Distinguishing between native and non-native speakers. This is a task that people have worked on with, silly accuracy in the past, and we get silly accuracy here, 99% accuracy. That's extremely easy. Of course, part of it has nothing to do with nativeness. It's got something to do with the fact that the data sets are different, right? The native speakers get more time and are asked to write longer. So, but even if you exclude, so the length features, of course, do the job for you. But even if you exclude the length features, the essay length features, you look at other things, we still get 98% accuracy, and that's again not very surprising. The best features are TTR, so richness of vocabulary, means sentence length. That's got nothing to do with the length of the essay. That's the average length of a single sentence. The homophonic letterhead, which has it has a variant that sounds exactly the same. And the discourse markers, I don't even see it myself. Can I raise this? I know I could. So the discourse marker in sum, which again is something that native speakers are taught in school, how to write essays, and they're taught to end their essay in sum. That's what I have to say. So yeah, these are not very surprising. Next task is to identify the native language of the author. As you recall, we have 3 L1s. Everything is even, so baseline random would be 33%. We get 77%. We never try to get higher. I'm sure we could. Just to maybe I shouldn't show that. It's harder for us to distinguish between French and Russian native speakers than it is to distinguish between French and Arabic, or between Russian and Arabic, and we think that might be related to the fact that French and Russian are, I don't know, maybe farther away from people than Arabic is, maybe. Here are the features that do the job, and this is interesting. So mean sentence length does the job. Of course, it does the job. It helps you identify Arabic as the first language because the sentences in Arabic are longer. We've known that. Now we get another confirmation. The definite article, definite article is a huge predictor of Russian. Again, we knew that. Now we see it in the features. The conjunction, the coordinated conjunction, ve, is a predictor of Arabic. Again, we knew that. The quantiles, so this means that Arabic native speakers use more common words than French and Russian native speakers. I don't know why, but that's an observation here. And then there are lots of other function words that are distributed a little bit differently and help us understand differences. Look at this. This is really interesting, and I can't explain that. That's the form of the letter P when it comes at the end of a word. And this is a good predictor of Arabic. And this is surprising because Arabic, like Hebrew, has this notion of different shapes of characters when they come at the end of the word. Actually, they have more distinctions than Hebrew does. The middle can look a little bit different. And again, this is a predictor of Arabic. Maybe it's a positive predictor. Maybe that's the explanation. All right. Last and most interesting task is predicting proficiency. And here we use an evaluation measure which is the mean absolute error between the prediction of the system and the average of the two human raters. So I remind you that the essays were graded by two humans from night, we don't know who they are, and they gave those scores of 1 to 7 to each component, which sum up to a score of between 4 and 28 to the entire essay. And this is what we wanted to predict, and we measure for the evaluation the absolute difference between the prediction of the algorithm, of the classifier, and the average between the two raters. And what you see is that the difference for the total score between 4 and 28 is 1.67 points. We're talking about points here, okay? The score ranges between 4 and 28, and our classifier can predict the score with an accuracy of up to 1.67 points along this range of 4 to 28, which means, you know, that we're not bad, right? We're not bad at all. In fact, we're better than the two humans, because if you look at the inter-annotator, that's not our annotators, okay? These are the night raters. The inter-rater agreement is larger than the agreement between our predictions and their average. Okay, so our classifier actually predicts the score as well as a human. And we want to understand how that happens, and here are a few observations. So first, we look at the features, and you see that the features here, the most important features are TTR. Again, our TTR is the best TTR measure that we find in this work. Essay length and the frequencies of words. So whether they are at the fourth quantile, these are the most rare, the rarest words, or the first quantile, these are the most common words. All these help to predict the score, but they predict the score in different ways, of course. I mean, the blue ones predict higher scores, and the red one predicts lower scores, obviously. And then you have the rank of the word, and you have some preposition function words, like this is the accusative marker, mean sentence length, and so on and so forth. So these are the features, the most prominent features for this particular task. And now let's look at the components, at which components. Okay, so we do some analysis. So the first component is content. Is the essay reasonable in answering the prompt? Our classifier did not have access to the prompt. We don't know what the prompt is, so it seemed, you know, almost impossible to give a score for that when we don't even know what the prompt is, what the topic is. And in fact, what we see is that the mean absolute error on this component between 1 and 7 is about half a point, and we do better than the human raters on content, which is surprising to say the least. Okay. Next task, the features that do the job on this particular case are again essay length, TTR, and the number of discourse markers. Next component is organization. Again, we do a little bit better than the human raters, and the features that do the job are TTR, essay length, and discourse markers. And also some function words like there is and also many. These are all discourse connectives in some way. Then there's lexical richness. We don't do as well as the human raters. In the task that at least I would think would be the easiest for us, because TTR is something that we all understand, we don't do as well as the agreement between the human raters, but again, TTR does the job, and also the accusative marker for some reason. And then lexical precision, which is a little bit vaguely defined, we do much worse than the human raters. And again, TTR is the most important, most prominent feature. Why is that? What's going on here? So we think we know what's going on here, and I'll say a few words on that. Summing up, I talked about the corpus of Hebrew essays authored by native and non-native speakers with 3 different ones: Arabic, Russian, and French. The corpus is not publicly available, but it is available for research purposes. You would have to fill a short form and request it, but you will get everything that we did, the corpus, the annotation scheme, the tools, everything is available. The corpus itself, we don't have permission to simply add a link to the corpus online, but we have permission to distribute it. And I think that it's going to be an amazing resource for studying second language in general, and in particular, the transfer from L1, especially for language pairs that are not really highly represented. I wouldn't say that these are all resource languages by any means, but they're not sufficiently well studied. Especially, I think it would be extremely interesting to see the differences between transfer from Arabic to Hebrew and between transfer from French or Russian into Hebrew, just owing to the fact that Hebrew and Arabic are Semitic languages. We also demonstrated that extremely simple models can identify L1, of course, distinguish between natives and non-natives that we knew, but identify L1, and more importantly, predict the proficiency score with extremely shallow features. We can predict the score better than humans. And the main question we have to ask is why, and I have the answers. So here it is. We have a very small data set, only 3,000 non-native essays. It's extremely biased, and it's biased by design because we don't have any essays whose score is below 17. So the range that our classifiers had to predict was always between 17 and 28. This is a much, much smaller range. And the fact is that if you predict middle, you're going to be right in most of the cases. And that's because the 4 components of the score are extremely dependent. And we see that in 2 ways. We see that one way we see that is the fact that the same features do the job for each of the components. It's the same features all over again. And the other thing is we look at the raters' scores, and we see that they also tend to converge to the middle, which means, I think, that what raters do when they evaluate an essay is they first form a holistic impression of the essay, and then they sort of break it up into 4 components because they have to, that's what they're required to. But I don't think that humans can actually disentangle, language richness from the organization of the essay. It's one called Gestalt. This is what we think. 2 more things that I want to mention here before I close. One is that we call these language aptitude tests, and we talk about the level of fluency of the speakers. Those scores are seemingly predicting something about the fluency of the speakers. This is wrong. We all know, everybody who works in this area knows that language aptitude tests measure certain things, that they totally ignore other things. And I know that as an educator in my classroom, there are students whose native language is not Hebrew. We have at the University of Haifa, we have in my department. The university has about 50% Arabic speakers. My department has 70% Arabic speakers. And some of them are extremely fluent in Hebrew, yet their Yael scores are very low, and vice versa. So those tests have to be taken, with a huge grain of salt. That's one thing. And the other thing has to do about ethics. These are essays that people offered in order to be admitted to universities. Nobody asked them whether they were willing to participate in an experiment of Professor Shuly Wintner, right? They wrote the essays before I even started to work. So we don't have informed consent from the authors. Having said that, everything is anonymized. We didn't get any piece of personal information from Knight. We got all the essays in sentence scrambled format, so there are no essays. There are like random sequences of sentences. And we felt that while we probably violate some ethical considerations here, no one is going to be offended from this work, and science is going to benefit a little bit. This is a touchy issue. Everybody talks about ethics nowadays, so that was due diligence. And with this, I would want to thank my collaborators on this wonderful project. The main spirit behind the project is Chen Gaffney, postdoc. The computational classification tasks were all implemented by a research assistant in Berlin, Isabelle Nguyen, and my two co-PIs, Anke Liedeling from Humboldt, Berlin, and Anat Prior from Education at the University of Haifa. I want to thank the three annotators, Livnat Herzig-Scheinfuchs, Hadar Klunover, and Gur Meir. I have to thank the funding agencies, so DFA funded the entire project. The DSRC at the University of Haifa funded the invitation campaign, and of course, we're extremely grateful to Unite for making those essays available to us. Last thing, I want to thank you all very, very much for your attention and for being here. I'd be happy to take questions.